Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here together to learn, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you.
Thank you, Rashmita. I'll just quickly share my screen. Okay, let me just quickly arrange the chat window. So if you have any questions, you can let me know that questions in the. I can just the chat is open in my secondary screen. If you have any questions, you can just put there, and we will be able to. I'll answer them on the way, and the rest of the questions I'll answer at the end of the session as well. So okay, let's understand what we are doing today, and I will zoom out. Okay, so check this out. So we'll be talking about the how to work with TensorFlow with Azure Machine Learning Service as such. Now, Azure Machine Learning Service is the primary service by which custom AI models can be created or custom ML models can be created in Azure. So can we use that with TensorFlow? Yeah, that's a big yes, but how do we work with it? What are the details of this service? Now, we also have the learn module over here, which you can go through after the session today. So I'll just quickly open it and show it to you. What is the, like after the session, like what's the next step? So if you just click on that link, and I will also give that link in the, it's already there in the chat window. You can see it's just pasted there by Rishmita. So you will notice that on that page, we have introduction to TensorFlow using Keras. Now Keras is part of TensorFlow only. It's already merged with TensorFlow. So they are the same thing. Now TensorFlow originally was very, you can say, or Keras was the one which used to abstract a lot of line of code which we used to write in TensorFlow. So Keras was a pretty nice, fresh, you can say, it was a pretty, you can say like a fresh breath of air when we used to work with TensorFlow because it was very straightforward as such. Now it's so popular that it got already merged in TensorFlow. Okay, so we definitely you can just go to the learn module, and there are more fundamental steps over there as well. But I'll just walk you through a couple of things which we'll be going through, and we'll be going through more than what I have in the screen right now. So you can say there will be an introduction to TensorFlow over here, where you can understand the basics of it. What is a basic data structure? What is tensor? What type of different type of tensors which are there? How do you work with the GPU? How do you enable it, disable it? How to define labels? How to work with data set? How to download it from various locations and make a training data set and a test data set? The basics of it. How do you plot it out? All those basics are covered in the learn module over there in a very step-by-step manner. You don't even need to have Azure subscription to do this. What you need to do is you need to log in, and then you can activate the sandbox. So in this sandbox is like an Azure subscription, which will be activated for you for a limited time, but you can comfortably finish the tutorial inside that. And you can activate many sandbox in one day. If I'm correct, you can activate 10 sandbox per day. So you can do it again and again as well. You just have to log in with your with one email ID. Okay, so now what is neural network? That is the next module over there, the basics of it. What is activation function? Uh, how will the forward pass happen? How will the backward pass happen? How do you work with the training and test data set in the neural networks? So the visualization of it, like how is the input image applied to the pixels, and how is it going forward from there? So all those things are very well defined in the module over here on TensorFlow. So how to make the predictions, and then you can also have a summary of it. Summary will also be having, you can say, like it combines everything together into whatever you have covered in the last different modules over there, and then uh, it just summarizes it in one end-to-end scenario like that. So this is the learn module, which we can complete after today's session. Now, what we are going to do is, that was pure TensorFlow, like how to get started with TensorFlow, how to work with it, how to define a data set, how to load it, how to iterate in the data set. And then the next part of it is the machine learning service. Like how do you work with what is Azure Machine Learning Service? And specifically, if I work with any library, then how does AML comes into picture? So that is something which I am also going through over here. Now, if you have joined me for the previous sessions, for the previous many sessions, you may have you must remember you will understand that we are doing a type of series as such, right? So we started from very basics many sessions back. I think 15 or 20 sessions back, we started with very with basics of everything, like basics of tensor, also basics of ML ops, basics of GitHub actions, and basics of everything, sort of CI/CD, ML, without ML, with ML, and so on and so forth. And now we are in every session we are combining all those things together, and we are working on. We are just building on top of each other. So today's session is relevant for anyone who is joining us from the previous sessions, and also even if you are joining for the first time, it will be very interesting for you. Now, so if you remember that in the couple of few sessions before, we were covering Spark, MapReduce, and Kubernetes, and distributed programming, and so on and so forth. So today is the session where we are discussing about TensorFlow, about convolutional neural networks. We will understand what are they, how do they work, and how do we work uh, how do we train the machine learning model using TensorFlow in distributed manner in Azure Machine Learning Service on Kubernetes. So is it something, if I just remove the Kubernetes part over there, it will still work, right? So even if anybody watches this video later on YouTube, then if you just skip the Kubernetes part, then it will be a simple convolutional neural network, which you can train, and using the learn module, you can uh, find that particular step over there. Okay, so I'll walk you through a couple of things which I have in the screen right now. And once I walk you through a couple of things, then I will start showing you how it's done and the details of it, right? So I'll just do one thing. I'll just start from scratch. Uh, and actually, sorry, actually, let me see if I can put it back. Okay. Anyways, so now the couple of things, like let's get started from the basics itself, right? So now the primary machine learning service in Azure is the Azure ML service. And to work with it, you have to create the workspace first. Workspace is like the uh, is the uh, is the boundary, or is the wrapper where everything is there. So with this, we create custom AI solutions in Azure. Now, I'll show it to you. So the configuration of what we are going to do takes a lot of time. It took me more than 4 hours to configure end to end. So I have it with me. Uh, I'll walk you through the steps, each and every line, which I have done over there. But I'll show you the end results first. So this is my Azure. This is Azure, and I will just zoom in for you. So we'll start putting things into perspective first, right? So the very first thing is you need the Azure Machine Learning Service. So I have one resource group here in East US. Okay, now one more thing. What we are discussing today is the is pretty cutting edge right now. Like the Kubernetes extension of Azure Machine Learning Service is in preview as we are speaking. So as of 12/3/2022, this the extension for Kubernetes, the AML operator for Kubernetes is in preview right now. So everything is as cutting edge as it can be. So maybe if you watch this video after a few months, it may be GA or maybe having more features than what we are discussing right now. So it cannot be more latest than what we are discussing right now. Okay, so first thing I need the AML workspace. So I have this resource group. I have deployed the AML workspace over there, and I'll just show it to you first, and I'll walk you through the steps on the way in few minutes. Okay, so this is my AML workspace over here. I will open my Kubernetes cluster also, and my Kubernetes cluster is over here. It is in East US, pretty happily running over there, and I'll just move it on one side. Apart from that, I have a couple of extra things also. So if you can see, I have one container registry. This is where Docker images are kept. Apart from this, I have managed identity MSI. So I'll explain what is that. If you know user assigned MSI, this is that. Kubernetes service bus also comes into picture. Azure service bus. It's an enterprise service bus. It's based on Apache Kafka. It has topics inside that. Topics are coming from Apache Kafka. We can think it through later on. So Relay is another service in Azure which does bidirectional communication, which also needs to be configured to make Azure Machine Learning Service work with Kubernetes and have the relationship between them. Okay, couple of normal things: application insights, key vault for security. Uh, I think I made two container registry because of some reason. Okay, I have one more. I'm not sure which one I used. I'll check it in the code. I think I have used the bottom one, this one where my name is there. So this is the one which we have used. We'll see where what is it doing. That's the normal machine learning workspace. That's one storage account, which is default data store. Okay, so this is this service over here. So which is this service over here where all the custom AI solutions are created. Okay, if we go inside this service, it has pretty interesting features over there. You can have a couple of interesting things like you can have this designer over here where you can just design these solutions without much of code. So if you click on something, you can see that here you will have uh, drag and drop functionalities. Now you can imagine how this one might be working. We have covered these things in the previous sessions also. So then what else do I have? I have this data set concept here. This data set is what we are using. We like understand how we are working with it, but we have one data set right now, TensorFlow mnist demo data set over there. So we'll see how is it coming. So data set is basically metadata. It doesn't have data inside it. It only is pointing to the either the path where the data is, and right now it is literally pointing to the path where data is. So the data is available on these URLs. So I have just pointed the data set to that path. I'll explain what is that. And now experiment is there. So this experiment is the one which I executed 1 hour back. TF AKS TF train reactor, and this is the one which took uh, not really 4 minutes, 4 minutes of running time, but the setup took more time. So, but this is the one which got trained in the Kubernetes cluster over there. Okay, so where is the Kubernetes cluster? So if I just zoom out first and show you the rest of ML service, we have models here. The trained models can be registered here. The endpoints, when you deploy something either in Kubernetes or you deploy it anywhere as such, those endpoints, the API endpoints can be listed in one location. It's for many purposes. Like one is definitely management uh, of the endpoints. We can list them over here. I haven't done it. We actually have done it many times in previous sessions, so we'll skip that today. Okay, compute instances are development environments. So imagine if we were not using our own laptop for the session today, what we could also have done is we could have created one virtual machine in using that option which was there. And this virtual machine will be called as compute instance. And this is where the development environment will be there with all the things over there, like Jupyter Notebook, Jupyter Lab, R Studio, and all that. So we could also have done the development using that. So it's development environment. Now we are not using it today. You can check out the previous sessions. Compute cluster is the one where we normally do the training. Like what happens is like when you, let's say you developed, you have developed the uh, convolutional neural network code over here. And now when you do the deployment of it, right? Like, sorry, not deployment, like the training of it, then the compute cluster basically will be CPU and GPU clusters which are there, which we have to actually create. And once we create, they start with 0 instances, but they can scale out based on your configuration. So the training actually happens in this compute cluster over there. Normally, that's how it normally happens. So this is where CPU and GPU clusters are there. Okay, that's compute cluster. So that is also possible in this section. Inference cluster. Okay, so I'll zoom in first. You can see I have one inference cluster over here, my AKS cluster. What it basically means is, let's say if I do any deployment, like I train my model, and then I do the deployment of that model, right? Then the deployment of the model can be done in AKS as a and will be can be there running happily with other microservices. So that is for that purpose. Now we are not doing the deployment today. We are doing the model training today. It's slightly different, but you can imagine it over here. Let's say if you deploy the model in production, this is the model here, and it is having an API endpoint and load balancing and so on and so forth, ingress controller, and all those things are there, which we are putting in one side of our today's discussion. So this is the AKS cluster, which is there, but this is these are the showstopper for the day. So attached compute. This is what we are using for training our ML models. Now, why are we using it? Why don't we use the default compute clusters and so on and so forth? I'll just answer those questions in a few minutes. Let me just show this first. So I have this attached compute. This is the one which we are using, the top one. The bottom one, I'll tell you what is the problem with the bottom one. Because things are in preview right now. A lot of things are not, you can say, they work as they want. So we are literally doing something which is as latest as it can be. So this is the one which we are using, AKS ML. And this is this is my Kubernetes cluster, this one, which is mounted over there, attached over there, not mounted. And we are using one user assigned MSI to connect with it. And this is where the run has executed in that cluster. Okay, so we'll see that. Okay, couple of interesting things. We have environments here. We are using some of the ready-made environments which Microsoft is providing. These are the base images which we are using for TensorFlow. So, and over here, so we call them curated environments. So curated environments are like ready-made environments which will be having the like TensorFlow GPU or TensorFlow or PyTorch, and everything will be by default installed there. So now it's not always that this has to be a Docker image. It can be just a configuration which is saved as such. So the default ones are curated as such. So we are using the default ones. Plus we had to do something extra as well. So we'll create some custom environments as well apart from that. So the custom environment is over here registered TF environment -TF, this one. So it is having these dependencies right now. Basically pretty basic things. TensorFlow is there, Azure ML default, Python runtime, and other things as such. So, okay, now the okay, so now okay, first thing is why what is the point of using Kubernetes for model training? Why can't we just use the inbuilt compute clusters which are there? Or is there any advantage? Why can't we just use this over here? Because in all the sessions till today we have done that. So why can't we do it today itself? Because first thing is we'll cover something new, and secondly, As you already know, Kubernetes is very it's one of the Kubernetes uh, is the de facto or default, or it's the most popular, or it's the is the popular orchestrator where we all the companies are running the microservices. So there is a pretty major shift, or there is a lot of customers ask me that can we increase the density of our solutions by using Kubernetes for as many things as we can. Like, why should I create a different CPU GPU cluster when I already have production grade, or you can say, or we have already multiple Kubernetes clusters, maybe in prod in other environments running in the company. Can't we just double up? Can't we just use that same environment? And this will, and it will help in reducing the overall cost, because we are able to use Kubernetes, and it's pretty nice as well, right? You know, the way it works. Like, we have the API server, etcd, scheduler, uh, and controllers over there. We can extend the functionality of Kubernetes by using operators. So Azure has created its own operator called as ML Operator, and it's not the only one. They install 5-10 extra things as well along with it. We'll see how many can we cover uh, to extend the functionalities of Kubernetes as such. So the scheduler basically finds everybody talks to API server. API server is the one which exposes the APIs. etcd is the bolt-based database for as key value pair. This is where the state is maintained. Scheduler is the one which binds the pods to the nodes as such, and then controllers are there. It's not in the diagram, but a lot of controllers are there. But for today, for machine learning purpose, we have specific controllers. So we have these operators, which are custom controllers, which are created by Microsoft to extend the functionalities of Kubernetes to make it connect with the AML service. Some other controllers are also there: framework controller, and identity controller. This one was the one which was in the preview instance. It is the one which was throwing some error. I'm not sure if that's a bug, or maybe I couldn't configure it. So it used to renew the tokens. It renews the tokens using MSI. So I'll tell you what it does. But other things are also there. Prometheus operator is there, which basically does the monitoring for AML jobs. So now Kubernetes, it increases the density of the solution. Here you can run your other microservices also of your company, and you can also run and in the last session I think we discussed about how to run Spark based jobs here. Today we are discussing how to run ML based jobs over there, not Spark, normal ML. So right, so it will increase the density of the solution. We can get the cost down, justify the cost, and so on and so forth. Okay, now how it's done. Couple of things which are there, which needs to be created when we do this. So I'll do one thing. I'll walk you through the code, and I will just just give me 1 second. Easy. Right, okay. Okay. Okay, so I'll zoom in over here. I'll walk you through the main parts. Okay, and I'll give you all these things as well, which I will show you over here. So the basic things, for example, if you want to work with Azure, obviously you need to connect with it and so on and so forth. So I'll just drop those things over there. So for example, you have to AZ login first and so on and so forth. Okay. Now, apart from that, I have this resource group created in East US AML RG. Now, one thing which I have done is I have installed the CLI extension in my laptop, the Azure CLI extension, because with this I will be able to make a lot of clusters and a lot of connectivities and connect Kubernetes with it and so on and so forth. Do all those type of things with that. So now the next thing which I have done is I have created the workspace in that same machine learning location. This is the one which I was showing it to you, the Shivam AML workspace over there. Now, couple of things which we need to do. Now, if you're aware of Azure, we have resource providers over there. these resource providers, they provide specific type of services. Like if I don't install the specific type of services, I will not be able to create those type of services later on. So these resource providers needs to be registered. So I have registered a lot of them over here. Maybe I okay, so if I just, okay, I think this one I just pasted 2 times. Okay, so operations management and these for monitoring purpose, Kubernetes container registry instances, compute, Kubernetes configuration. These are normal, but these needs to be installed for you to be able to work with what we are going to discuss. Now, a couple of more things. I have also created the Kubernetes cluster in EastUS. Now, minimum, remember one thing. Now, for you to be able to work within production over Kubernetes using Azure Machine Learning Service, there is a concept called as fast pods. You need to have minimum 3 nodes in the cluster. Otherwise, it's not a prod level. Production level configuration will not be possible. So some default baselines are there. So because of that, we have started. And if we do it in dev and test, then we can have 1 node count as well. But that's one, just FYI, if anybody wants to, is later on doing it. 3 for prod, pods, look for that. Okay, so 3 node cluster is coming up in East US after that. Uh, and You have to install Cubectl as well if you don't have it. So Cubectl is here. If you get any error installing Cubectl, you just look for the other ways in the Kubernetes documentation to get it from there. So basically, after that, we have to connect to the AKS cluster to get the configuration. If everything is fine, you will be able to run the Kubectl nodes. So if I just run that, you will see that I have to zoom out first. It's just too zoomed in for me as well. Okay. So, okay. So yeah, things are working fine till now. And you can also sort of get the other things as the other things as well. And the sorry, I think it's a space without space or something. Okay, I'll just put this in 2 lines. You can run multi commands as well. Let's check out this space. Okay, so now okay, so you will notice that I have a lot of these pods which were supposed to be configured. And we are just focusing on the ones which we have in the Azure ML namespace. So let me see if I can just get them out. Okay, so please notice these. So some cube state metric, Prometheus operator, AML operator. This is the one which I have in the screen. This one over here, the blue one of the main ones. The REST API server, these cluster state, some blob connectors, which will connect with which will mount the blobs. This Volcano is used for you can say running high intensity workloads. I'll see what happened with those two. But the scheduler and controller for Volcano is pretty happily running over there. Okay, so now how did we install these, right? So I'll just take you back. Like we have to do some configuration to install them first. So I will uh, go to that specific part. Okay, now the service, the Kubernetes connected with AML isn't needs to be when you use it, you have to install this feature which we have, which is called as AKS Extension Manager. It's part of the this resource provider, Microsoft.container resource provider. So now it is available. Okay, now as of today, it is if you want to do this, do it in East US. Don't go for other locations. Uh, so the documentation does say that it is possible in other locations like East Asia and so on and so forth, but practically it doesn't work. So it's in preview right now. Go for the old regions to make it work. So the configuration has been done in East US for this. Now, okay, the main thing. Now we have to install so there is one concept called as extension in Azure in Kubernetes. So what these extensions do, these are like Helm packages, similar to that, and they literally at the backend uses Helm also at in some locations. But what happens, like if I had to configure uh, the AML service to work with Kubernetes, that would, and it really installed so many different pods over there. It created so many pods over there, so that would have taken us a lot of time to do it one by one. So there is one, you can say extensions are the packages which are available, and it's from Microsoft only, which will do a lot of configuration for us in the Kubernetes cluster. So this needs to be installed. Now, this is locally getting added, and then the main command is over here, which does it inside the Kubernetes cluster. So AZ, Kubernetes extension create, that's the name of the extension as such, like the name which we are giving. The extension type is this one. Now scope cluster type, cluster name, the name of your cluster, resource group is your resource group. Now this is important over here, managed clusters. So if you are aware of Azure Arc or not, I'll just see if I can find one easy diagram for that. Okay, so what happens if this is one of the topic which is coming up in future, but let's say what happens if your Kubernetes cluster is not running in Azure, it is running, or you have multi region clusters or multi cloud clusters also over there, and you have clusters in GCP or on premises, or maybe you have clusters in AWS, or you have clusters in anywhere, on-prem cloud, Azure, on-prem in your laptop, somewhere practically in the world. So we have this thing called as Azure Arc, which connects all the Kubernetes clusters together. So what that does is, if we, so right now the cluster is in Azure. If not, this would have been over here called as connected cluster, and then the clusters may have been anywhere in the world. We would have done few more connections, but then we would have been able to run the machine learning models, or the machine learning models would have been deployed or trained against those Kubernetes clusters wherever they are, Azure, AWS, GCP, on-prem, and in other clouds also. Wherever you want, you can make it work. So it also, whatever we are discussing also works with Azure Arc. This over here will become connected cluster. Okay, then the normal things like the training. So what the other configuration which I want to show you is that we could also have done something like this. So I'll just show it to you. So we could have just said that, okay, enable training. Training means we want to do the training of the models over there. So we have to be passing one argument to enable it in the EKS. Then do we want to do inferencing or not? Inferencing is inferencing, like scoring. So if we were deploying today, then we would have enabled that also, like this part, model deployment, which you can do from the learn module. Now how do you are you using HTTPS or not? This is where you have to configure. So right now it's no. Uh, Otherwise we have to configure the certificates as well. So this is the advanced configuration of this. Okay, now we are done. That's all. Once you do this, you will be able to. It will be will start working from that point onwards. This is all. Now after this, we go back to the machine learning service and we go to the compute. You can do this step from the command line. Also, you can do it from the UI as well, Kubernetes, and give any name of your choice. Select the Kubernetes cluster, which is right now in your subscription. Give any namespace where you want to do the model training. So the namespace right now for me is Azure ML, the one where everything is deployed for me inside AKS. Okay, so all of this is done. Now, little more about the MSIs at the backend. So what has happened is I was able to attach both of them. So the Kubernetes cluster is now attached with the AML workspace, and this is not right now over there as the attached compute over there. So attached compute means like the external cluster, which will be now the density concept which we thought about, that will start playing a role over here once we develop and we use the same AKS. Okay, now to make it practically work, we also need Azure Active Directory to give some tokens over there. So this is Azure AD. So when we do the configuration, there are three ways in which we can do this. With service principal, that's one of the older way of working with Azure. Service principal is via app registration. Some of the newer or simplified mechanisms of working with this will be using the MSIs which we have. So managed service identities. So we have two of them, user assigned, which we are using right now in this example, and there is another one, system assigned. System assigned. So the meaning of that is like the management becomes easier of the identities. So if I just summarize it over here, how will it look like? If I use the system assigned MSI, it will be binded to my AML workspace, and then I have to give some rights to it on the AKS. So this is RBAC over there. This concept is the bottom one over there. So if tomorrow I delete my AML workspace, then identity is also gone. There is no dangling identity in the Active Directory. Nothing like that happens. We don't have to manage it over there. This is the bottom part. Second one, the user assigned MSI is more, you can say, is managed differently. So in this scenario, we have to manage it in the as a resource in the resource group. So this is the MSI over here. Now this is having the rights on AKS RBAC to be able to do something, and this is the one which is assigned to the AML workspace. So over here, and this MSI is having its own token endpoint inside the Active Directory. So whenever it needs to get the access token, it will get it from the Active Directory like that, and will make both of them talk to each other, or rights will be there on each other. So if I just go back and show this to you, so here we have the MSI which is created here in the resource group, and this is having, it is connected to the AML workspace and having rights on AKS. Okay, now okay, so this is all the baseline infrastructure. Now, a couple of just two more things, and then we are done with the entire setup. The Azure Relay is one service which is like a bidirectional connection which we can create between one Azure service and anywhere else. Like so what they have done, but here they have created Azure Relay between the AML workspace and Kubernetes. Now, the purpose of this Azure Relay service, which is configured, and when does it gets configured, right? Do we have to do it? No, not really. So when you install the extension, right, in that one line, everything happens. So in which line, if I just point it to you, let me show you that over here. When you will run this, then then a lot of setup will be done for you, a lot of setup. So over there, which you don't have to manually configure. But if you want, you can definitely go and troubleshoot it later on. So this is a bidirectional connection. What it does, it routes the traffic from the Azure machine learning workspace to AKS. Like if you submit any job, then this one sends that job or sends the traffic to AKS saying that do it, right? So how does it work? Like how will it work? So if I just use some colors over here. So let's say you submitted the job. So that's me using something to submit the job. So this basically goes to the API server. Now what that API server will do, basically it will go and one of the controller will create the will say that okay, this pods needs to be created, some deployment will be there, and some replica controller will come into picture. So all of those things you can check in the previous sessions. Okay, now then we have this custom machine learning operator which will get triggered, and this guy will they are watching each other. There is a binding which it watch, and it will pick up the deployment, or it will get triggered, and it will start you can say negotiating for the resources, and it will finally get the training pods deployed over there. A lot of things will happen when I said that it will get it done, but a lot of steps will be there. But typically the Azure machine learning pods will start coming up if everything is fine with the as such. So Azure machine learning operator manages the entire model's lifecycle, and this is the one. Okay, now whenever something goes wrong, there is one pod which will get created, the gateway pod. If you work with Azure, this gateway can be other gateways also which we have. So now using the service bus, this gateway basically sends the job status of the job and status of the cluster back to the machine learning workspace. So what is this doing? This basically is the reason why I can see that I am getting some data here back. Like if I click over here, if I can see some logs over there, let's say once I click on something over here. So anything which is happening, like any status which is coming of the job, or is it running or not running, completed, failed in middle, or queued as such, all of that traffic is coming over these topics which we have in the Azure Service Bus. So this will get configured automatically, and one gateway will be using this to sync the job and the cluster status with AML workspace. So one thing in the middle over here. Now, so this is the all the setup of how do you make both of them talk to each other. Now, the old year old things. What is convolutional neural network, right? So today's topic is convolutional neural network, and I will run you through one of these slide deck which I have, which got opened in the wrong screen. So I'll duplicate it again, and we'll just run you through this. Now, okay, so check this out. So convolutional neural networks are the ones which are depend. You can say these are the ones which are inspired biologically, and they were research which was done in 1960s as such by various scientists which we have over here. And they in 1950s and 1960s they did the research on the retina of the cat, and they found that there are different type of cells over there as such. So some of the cells they used to get triggered when the light was we used to shine the light on the middle of the cell. So they used to call this center surround cell. If you shine the light on the entire thing, doesn't nothing happens. So then there are also different type of cells which they discovered in 1960s. So these are the cells where if you shine the light in a particular orientation, then those cells used to get triggered in the cat's retina, or you can say in the neurons which are there in the dead cat. They used to get triggered. These diagrams are very basic. Just look up in any you can say any website where details are there, and you will be literally you will be amazed how much your brain captures when you look at any picture. Literally it just gets sort of embedded in your on your neurons. So these are pretty basic diagrams. Maybe in one session I'll show you the real ones as well. So otherwise look up for them. Now okay, so here we also have cells which detect motion. So this is what convolutional neural network also does. It extracts information from various using various layers, and the from the pictures, and then these then we have the various type of layers over there, convolutional layers and pooling layers, and then we finally get the uh, classification done on the data, or we use the it for other purposes as well. Like we can also do, if I really think it through, this is the overall architecture of CNN, and we can do disease diagnostics. We can identify the from the X-rays we can find whether it's COVID, you are having COVID or not. Object tracking can be done. OCR can be done. Semantic segmentation of images can be done for robotics, autonomous driving, precision agriculture, and so on and so forth. So it can be used. So few of the elements of convolutional neural networks which are there are these. Like three main elements are these: convolutions, pooling, and feature maps. Three things are there. So if you think of any image, this is how images looks like, binary images. This is how colored images are there, right? RGB planes are there, and they will be having different pixel intensities over there. Now, grayscale images are like that, and you will have intensity between 0 to 255, representing the grayscale. Now, these are the three elements which you can work with using any of the library, including TensorFlow as well, right? In the learn module, that's what we have to now perform. So convolution steps is this. Like there is a filter. If you work with in photography, if you have any pretty expensive cameras and so on and so forth, you have a lot of lenses, then you already know what I mean by filter. You can put those different lenses, and you can get different effects. Similarly here, we don't have those expensive things. We just have expensive GPUs. So the convolutional filters, they convolve over the input feature map, input image, and they get they extract the information as weights as such. So these are the main things. Like filters are the main things. The kernels are the main things. The middle yellow thing over there, and we can have horizontal. They can detect horizontal edges. They can detect vertical edges. They can also detect horizontal edges. They can detect different type of edges as such using different type of filters. So if we can learn the filter weight during the training process on your custom data, that is what will help us in doing the classification of images if we are looking for that in the so you're going to work with the mnist dataset. Mnist dataset basically is having those uh, digits are there like fashion mnist, or you can go for the generic mnist where characters are there. So then we have to do those image classification as. So there is one thing which comes is called a stride. Like when you are moving that filter over the input image or the feature map or the somewhere in the middle of the entire flow, then the stride is basically how many units are you moving it around which. So this is having stride 1 right now. It is 1 stride. This is so padding. If I don't put padding over there, the filter will spill out of the input image. One thing that's possible. Secondly, if you can see in the previous diagrams also, there was like a funnel, right? It was shrinking down. So size will shrink down before you are able to practically extract the features from your images when you are working with very large data sets or large image sizes. So you have to put padding to be able to control how much things shrink in the subsequent layers over there. That's a normal RGB, you can say, based image over here, which uh, you can say the filter is now running on all the RGB3, all the 3 planes as such. So if we can learn the weights, that's what convolutional neural networks will achieve. If they can achieve the correct weights, then that will be very helpful. That's a pretty common activation function, ReLU, which you are going to use in the learn module as well, where which will basically make the negative values diminish, or they will convert it to, you can say the output of this is literally 0 over there. So it, you can say that the features of the input image which were not really important are now diminished as such. Max pooling is this. We are going to use max pooling, and the max pooling will be we have average pooling and max pooling, two common type of poolings, the original ones as such. Now you can see it's pretty obvious what it is doing. If you can just if I can hold it somehow, so that 9 went there. So the pixel with the most intensity is the output. In average pooling, it takes the average of it. So here average pooling is going on where 9465 averages is 6. So in convolutional neural networks, everything comes together uh, in these layers over there. So what we are going to do is, if I just close this slide deck now, so we have to, so what we basically are using our laptop, not the compute instance for no reason. You can use your laptops also. So now I have VS Code over here. I have the entire setup done of my Kubernetes cluster is right now connected with Azure Machine Learning Workspace. We everything is right now working. Service bus is there communicating. The relay is also doing bi-directional communication. MSI is making is the one which is authorizing and authenticating whenever some one service needs to work with another service. Operators are in place to handle to understand the submit of the job, or the run will be handled by them. They will also update the experiment over there for the with the status over there. So everything is ready. Now what we have to do is we have to submit this. So you have to write the, let's say, so what I am calling it as is a train.py file. So train.py file is my training script, like the training script. So where the training will be the code is written of CNN. So over there, right? So where is the code? If I just take you back to that learn module. So if you go back to the learn module, this has been picked up from that link. over there. So after the session today, when you will do that, you will find that train.py. Just copy paste whatever you have in the last step over there. Okay, now what uh, other things? Okay, so train.py is my training script, but that doesn't mean that is like a normal TensorFlow code. It doesn't have anything specific to Azure ML. So how do I submit it to Azure ML? How will I tell Azure ML I want to use that AKS cluster to do the model training? That part is where the AML SDK comes into picture, Azure Machine Learning SDK. If you work with Azure, you have to sort of learn this, and it's not very big. It basically some X number of functions will be there or methods will be there. So learn it. It's like boilerplate code. Once you learn that, it always remains same. Rest is your train.py file, your training scripts. That's where the world is there. So Azure ML is just like some of the boilerplate code. Okay, so where is it? Let's have a look at that. So I'll just walk you through the main file over here. You obviously have to install uh, the Azure ML SDK. So don't install everything. You can just install the Azure ML core and one more which we are using, data sets, which I may have installed later on. So this is like simple things, Azure ML .core, get which SDK are we using right now. Okay, now we have to connect to the workspace. This workspace is in the cloud right now, right over there. So how do you connect to the workspace? There are two ways. Either you can hard code all the information or you can use one configuration file. So I have downloaded the configuration file from of my or you can create it manually as well. We need three information: subscription ID, resource group, workspace name. Three information. You can hard code this there also, but it's better if you work with configurations file, which can be further maintained securely using other concepts like keywords. Not the values can be managed there. Now, the okay, so the AKS we are connecting with the AKS cluster. So this is the one which we have configured earlier, and this is the one uh, which we have connected over here. That one, the AKS one. Okay, now and it is already available, so it is found, and that's a pretty big dump of output. But basically, it says that it got found. It is running in some AML resource group in my subscription. Succeeded. East US user assigned MSI is being used. That's my subscription, my dummy account right now. That's my Azure AD. This one, that's my subscription. Now, okay, then the data sets. So we how do you give the data set? Like, should I upload it manually? But if I have very big data, then that will not make sense. So what we can do is, if your data, we have this concept of data sets, right? This one, the second one in the list right now. So these data sets are metadatas, is metadata. So it doesn't have data, but it can have references to the data over there. So what we are doing, we are creating one list. We are saying that, okay, there are 4 URLs where data is available. You register it. Okay, so we will specify it, but we will register it in the AML workspace. That okay, these are the 4 links where the training test uh, and the X test, X train, and all those are available over there. So we do that. We specify the web path that okay, data is available there. What else can I do here? I can also have the data in the storage accounts. I can also have the data in the data lake. I can also use the Azure SQL as well, or Postgres databases to store my data and read from there. Or if you any other thing which comes to your mind, we will be able to we can say work with those. So okay, now so we are just using these and we are registering them. So as soon as you do this, so this is where you can specify something which is more relevant to you. So mnist data set for TensorFlow demo in Reactor, some description of it. Version true. This is a good feature of AML service that it basically creates dataset versions. In case I work on this, I clean it up further, I do feature engineering on this, so I can register it. If I any major or minor change which I do, maybe I will change the name if I do major changes. But in the end of the day, everything is registered as with versions over there. So I don't have to maintain the versions of my data set separately or using any other service. It's there only. So if I just click on it, it just shows these versions here. If I run it again, it will say version 2 there. And then I can later on, I can roll back. I can use any version. Rollback is not even required. I can use any version as such. I can specify with versions what do I want to work with. So, okay, register it. Now, okay, working, it's registered. Now, okay, so okay, now this is one thing which is very typical. What happens? You have to specify one script folder. So the reason we specify the script folder is because this folder will get submitted along with the job, and every file which is there will also get uploaded to the compute target. So for example, your train.py should be there in some folder like that, and anything else which you want. Maybe there is a preprocessing.py, so process data.py or something, other files which are there. This folder will get submitted along with your job. This will get uploaded or will get mounted uh, as such. So we typically you have to do this. So create any folder of your choice, whatever you want, put it there. So I have, apart from my tf-train.py, which is lying somewhere here. I have this utils.py. Utils.py right now is needed to extract the data later on. So it will make sure that data set properly get extracted. So any other file which you have to pre-process data or any other type of logic which you're thinking of, you have to have those files which are needed during the model training in some folder, which can be submitted during the run. Okay, now create one experiment. So experiment is like that umbrella where everything will be logged. So in Azure Machine Learning Service, I have this experiment created, TensorFlow reactor demo something. So where I can see the run IDs, like how many runs were there, how many failed, how many executed. I'm gonna further go and troubleshoot it or find it or trace it after 1 month over there. So we have this AKS train reactor. So this is over here, this one. So that step basically creates uh, that one. Now, okay. So now we can also work. So the good thing about ML services, you can also register your environments there. Like I may have to, my colleagues may also want to work with this maybe in future. I may have to work with this environment in future. So the environment is basically all the dependencies which are required for the model training. And this environment I can also use later on if I'm doing the model deployment, and then I need the dependencies in the base image, then I can double this up. I can use it there also. So this is pretty practical. So you give any practical name, specify whatever you want. You can specify in line also. You can use YAML files also to specify your dependencies. If you're using any base image, so we are using base image here, which is provided by Microsoft. Otherwise, you have to make it yourself. So if you don't use the Microsoft's base image, which may or may not be the practical thing to do in production because it's not in your control, then one thing which we generally do is if you remember, we were discussing that there is one thing called as ACR also in the starting. So this is ACR, the container registry. Uh, let's put it there. So this is the ACR where Kubernetes, this has to be connected with Kubernetes because the images will be pulled from here as such in our example. So in future, if you're doing this, make sure that you have connected this with AKS. So you do your Docker push over here. So let's say this is uh, that's representing Docker push, and this is the final image over there. That's the CI pipelines output, right? The artifact is there. So this is uh, the 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 base image over there, or the image which you're using. So now then you have to specify your exec path, and you should have the rights to pull it, which you should be having if you have connected the ACR with AKS. It will be taken care at that point. But then this will not be MCR. It will be, for example, Shivam's. I gave some name, Shivam CR dot Azure CR dot IO, like that. So it will be that. Okay. Now that's where we define the script run config. This is one function which they have inbuilt inside Azure ML SDK. That's the main function. What it does is it just summarizes everything and submits it. So you have to specify the script folder. Script folder is that a folder which we were having on the top, the orange one. Now the which is the entry file, like the main file. So train.py is our main file. Compute target is Kubernetes. We have it configured. It's coming from the top. Environment is that environment which we registered. Arguments are literally arguments will be like at runtime. What are you passing? Like if you want to customize any, uh, like arguments will be like your data set name. So our data set name is Tensor TF something reactor demo like that. So all those arguments can be further more arguments as well. Okay, this is when the run starts over here. So this is where you submit it. So this will actually will trigger all the mechanism, and the operator will finally will come to know that someone is trying to deploy, is looking for executing machine learning model, training the machine learning model. Then the ML training pods will come up in some time. All the communication happens with relay and service bus, and you will be able to see the details as well. That then you can also go back to Azure portal to see more details, like did it executed or not, and so on and so forth. So you can find it here as well. Like it will say completed and so on and so forth. I can also find the same information from the attached compute run ID, but that doesn't just takes me back only. So it's nothing special. If I go here, I click back, it takes me there only. So it's the in experiments, you can just go and find your things. Why do we log it? You log it uh, because we can have tags, we can have the different matrices which are there. We can log all this, we can specify, we can have pictures also logged, images, all the plots which you are creating can also be logged, traced later on, and you can know which hyperparameters you have used. You can keep all the information under one experiment. So logging is very practical, which is provided there. And so we train the convolutional neural network using the uh, by using Azure Machine Learning and uh, AKS and so on and so forth. So this is what I had for the session, and I have already shown you the next steps which you can go to further. Definitely go and subscribe to the YouTube channel which we have with the name Microsoft Reactor to find the previous sessions, and join us for the next upcoming sessions. Also, we are doing some very interesting sessions using uh, NASA's data as well. So join for those as well. See what we are planning for you. And this is the learn module. The link is there. Uh, Go and you can complete this. There is nothing which is required. No subscription required. Sandbox is available. So this is the next step. Now do it over here. All the steps will be there. Now apart from this, please ask your questions. You can also unmute and ask your questions as well as soon as the audio channel is available to you. Let me know what comes to mind. You can also find me. I'll just put the other things as well. The my LinkedIn profile is also going in the chat. I will put the learn module as well. So you can find us and join the Reactor group on LinkedIn. I'll share that. In the meantime, put your questions in the chat.
Shivam?
Yes.
Yeah, no, it was a great talk, but I'm not able to see the chat, the questions where to put in these teams because.
Okay. Possible. Maybe because of the if you're using web client or maybe the
Yeah.
laptop. I don't know.
Mm-hmm.
No
Yeah,
problem.
that is the reason.
Just go
No,
ahead.
so the means in this setup, basically, how will be the means how to track the pricing or the cost? Like what you do, because as we know, like the data set, it requires more compute and basically like AKS and all those things. Whatever we have is like are expensive stuff. So what are some recommendations to before pushing it to or using this, can we train and model something and make sure like it works something locally and then use all the services? Or what do you suggest, like how should we do when we are basically testing it and developing it? Or should we start directly on the Azure, or
Okay.
basically
Now,
take a step back and just use like the main things and then transform to this setup?
correct. Now, so for example, let's say I want to do this locally. So literally, we don't need to spend any money. We need to have Minikube in the laptop at least. So this Minikube uh, will be the one node sudo Kubernetes cluster. So for
Okay.
example, I'll give the link. We can
Hmm.
install it from here. Step one. Now, the second thing is the Azure ML SDK is just an SDK. So just a SDK.
Hmm.
So we can install it directly in the laptop. So we don't need to go for the SDK. Now,
Hmm.
if we do not create the workplace, the workspace of AML, then the logging part cannot be tested. Those things will become difficult. So some minimum Azure subscription requirement will still be there. So
Okay.
we can go for the free trial of Azure or use the sandbox type of things which we were
Hmm.
uh, thinking of. So I'll just
Okay.
put the name of the free trial. So this free trial can be
Hmm.
also can be redeemed over here.
Hmm.
Now, okay. So once we have this, then rest is just Kubernetes. So then we will install the same operator, but in our
Hmm.
laptop itself, and everything once locally we see it is working,
Hmm.
then we can go for the cloud environments. Okay, now the pricing part.
Hmm.
The when practically one day when we'll go for the cloud, the
Hmm.
only way in which we can correctly uh, calculate the pricing will be
Hmm.
using the pricing calculator. So
Hmm.
we have to go for this, and here we have to look for those individual components which we are using.
Hmm.
Like, let's say we are going for Kubernetes, which is literally here.
Hmm.
So then if we are using data set doesn't have data, so that's not the cost. Data
Okay.
store will be the one where your real data will be there, like data lakes
Correct.
or some SQL cluster, SQL
Hmm.
database or somewhere. So those that will cost will be there. So you have
Hmm.
to look for it like storage account and enable and then select the data lake option there. So then
Hmm.
the cost of storing the data. And then if I'm using the machine learning workspace, then what is the we don't have any, so we don't have any GPU CPU clusters here. So,
Hmm.
but we will, but that cost will get added in AKS because there we are trying to increase the density of the workload. So why companies are going for this is because Kubernetes is very practical, and the modern DevOps approach of CI/CD
Hmm.
makes it. Kubernetes is like de facto will be
Yeah.
there.
Yeah. I know 100%. Yeah.
Like this, we'll calculate the cost. So AKS cost
Hmm.
here, then store the data lakes cost over here. How much
Hmm.
are we keeping over there, and how much transactions are we going to do with it? And Azure machine learning cost here
Hmm.
without any CPU GPU because we are not using it here. We are using of AKS. So then overall cost will come in the bottom of the page over there.
Hmm.
This is how you can see
Okay.
cost
But
part
compute is not needed. Means, as you told, the compute would be inside the AKS itself, like you mean to say,
will
right?
be here in
Yep.
AKS. We'll calculate it here. So
Hmm.
like one virtual machine. So I had three running over there.
Yes.
So
Yes.
then what the size of it? So
Hmm.
some size of it, then that cost will come up. Now just one thing, now it will be slightly difficult just for us uh, to calculate it correctly because
Hmm.
today we can do it, but practically in if we think of production environment, we are
Yes.
not the only one who's using it.
Correct.
The some other teams are also deploying their front ends over their
Hmm.
e-commerce website, theirs, and so on and so forth.
Hmm.
So then we have to maybe see the overall cost and how much CPU are we utilizing, how much compute are we utilizing,
Yep.
and then divide it and justify it. So that thing will be
Or
custom.
else we need to have a separate Azure blade itself, like a separate yeah, blade instance for ML, means for machine learning, and for the others in the company, like a separate blade, so that for the so that then you can have the separation itself completely.
But then the cost, that density thing which we were trying to achieve will
Mhm.
become challenging. That we would like to so density basically will be like run as utilize your hardware
Correct.
as. Yeah.
Right.
So
Understood. Yeah. Then we'll lose out that thing basically. Then in
cost,
that
yeah.
case, no, makes sense. Makes sense. And thanks for this explanation. And with your diagram, basically, to understand it is much better instead of just the plain text. Um, yep. So the next thing is basically you mean to say like follow that link which you shared, which is the TensorFlow with Keras, and and after that, basically for the next session, I guess that would be a continuation, right?
The we will so generally the sessions are independent, more
Okay.
or less. But yeah, definitely whatever we have covered till today, we will
Mhm.
definitely use it later on. So you guys will learn more in the upcoming sessions.
Okay. Perfect. Thanks.
Okay,
If
so yeah,
Sorry, Shivam, please go ahead. I was just about to say that, if you have any more question, please feel free to ask. But yeah, sorry, go ahead.
same thing. I was just putting that up only. So okay, so please find the learn module in the link book in the chat. Bookmark it. Do it. If you have follow up questions, find me on LinkedIn, and follow join the Reactor group. Find us for the next sessions, and find definitely join the meetup page as well to get a list of all the amazing sessions which are going on. And have a nice day.
Thank you
Thanks.
so much,
Thanks.
Shivam. And thank you all for joining us. Like Shivam said, you'll get all the link, the Learn module link, the Meetup link, our YouTube channel link, all in the chat section. Let me also share my screen. So just in case if you want to note down, please feel free to do that. Please visit our Microsoft Reactor pages. There are a lot many more interesting sessions that are coming up. And thank you all for joining us today and enjoy the rest of your day.
Thanks,
Thanks,
guys.
team.
Thanks a lot. Really appreciate it.
Thank you.
Thank you. Thanks everyone.